Hello, this is lecture 2 of mlcourse.ai. It's about data visualization. So if we go to the main site, mlcourse.ai, we'll see two parts in this topic. So the first one is general about visualization, and the second part is about Seaborn, Matplotlib, and Plotly. So if you study it thoroughly, you'll see that it's pretty much material. So first, typical plots for visualization, like histograms, box plots, bar plots, and so on. The second part maybe is a bit more specific. It's about concrete tools like Seaborn and then Plotly. So here I'm not covering Plotly, so you can dive into it if you'd like to. My motivation for this lecture is to tell you what plots you typically build when you first see data. So like with pandas, we started from the very first steps you do when you've got data, and here with visualizations I'll also go into the most crucial plots that you'd like to build when you first start actually exploring your data. So typically it all goes together. Preliminary data analysis with pandas, just calculating some statistics, some numbers, and visual data analysis, it's all intermingled, so you can't say that from this point I start building plots. It all goes together. We'll work with the very same Churn dataset as in the first lecture, but as a motivation I'll show you our competition. It's about user identification on the web. So it's tracking user web sessions and identifying, distinguishing actually between some Alice and somebody else. So we'll cover this competition in detail in lecture 4. But here I can show you that with Kaggle kernels you can actually find lots of nice examples of EDA, Exploratory Data Analysis. So typically it includes both preliminary data analysis with pure pandas and building some pictures. So pretty much in every competition, if you just find a kernel with EDA, Exploratory Data Analysis, you'll find some nice examples of building plots, nice figures, some speculations about that, what conclusions can be drawn from this. Okay, so closer to the end we'll see more and more figures and plots. Okay, and so in this Alice competition, visualization is really important. So it's really easy to create some useful features there, and so typically you create them by tracking, by actually plotting making some plots and actually checking the distributions, let's say for Alice and for others, and with plots you can actually get some intuition that the feature is going to be useful. Okay, just as an example, here's a feature start hour of a session, so 7 a.m. in the morning until 23 in the evening. So these plots compares the distribution of these features in train set and in test set, but it's just a random plot. So typically it's really very important to build such plots when you have a target variable, and so building plots separately for different values of target, let's say for Alice and for everybody else. Do we have such examples here? Not sure. Okay, but we'll be definitely building such plots. And if you go just anywhere on Kaggle datasets, so it's really a very, very cool collection of datasets. We can sort these by votes, let's say. And I will take a look at European soccer database. So it's really very easy to find some nice examples of visualizations if you just go to kernels, and you can also sort by votes. And typically exploratory data analysis is something really popular, and people like nice plots. And let's just click on random. Okay, introduction to data science with data science AI, let's say, and most probably we'll find some nice plots here. Okay, in this data we deal with SQL, maybe I'm not really lucky for the first time, but typically the most popular kernels are about exploring data and about building nice pictures. Not only nice, but leading to some intuitions about the dataset. Okay, so this kernel is pretty long, so requires some time to load. Okay, you see all these fancy visualizations. This time it's a diagram of transfers between different leagues. Okay, so actually Kaggle is a really very nice source of plots like this. What I'm going to cover is actually when you first have a dataset, what plots you'll typically do. Okay, so just a small intro. We'll have a dataset, and first we'll build some plots depicting the whole dataset once at a time. So it will include something like correlation metrics, histograms of all features, maybe something else. I'll tell just a bit about TSNE, a very funky and cool technique to gain some intuition about the distribution of the dataset. Just as I would say, looking into all these d dimensions, it's not possible, but with TSNE you can somehow project your data on a plane or in 3D and to get some intuition about data distribution and data peculiarities. Okay, then we'll go to exploring single features one by one. And it totally depends on types of these features. We'll distinguish numeric features and categorical ones. So binary is a special case of a categorical. There are also some ordinal features that resemble categorical, but they have order between values. We'll just stick to categorical, meaning there is no particular order between values of the features. And so it's not necessary actually for visualization, it's not necessary to treat ordinal features as something different. Okay, and then we'll take a look at feature interactions. So depending on these two types of features, we'll have three interactions between a numeric feature and a numeric, categorical and categorical, and finally numeric and categorical. And for all these cases, I'll tell you how to explore data without plots, just with pandas or maybe NumPy, and what typical plots you'll do in each case. Okay, let's start just from scratch. I'll read the very same dataset on telecom churn. So I'm importing pandas SPD, and I'm reading telecom churn data. Let's call it df data frame, pd read csv. We'll read it from csv file, and if you fork the repository, it's here in data telecom churn dataset. Okay, with head we take a look at 5 first rows, and we see there are a bunch of features here. Like, let's take a look at the shape of the dataset. So I'm moving it up a bit. Toggle header, toggle toolbar. Now we've got more space. Okay, so the shape is 3, 3, 3, 3 rows and 20 features. And we'll start exploring all these features, but for now let's just take a look and see what feature types we've got. So state is definitely a categorical variable, so the values of state are not compared to each other in any way. We can only say whether they coincide or not. Account length and array code, this look like numerical, but we need further investigation. So actually, with first models like logistic regression and random forest, we'll start understanding whether features are useful or not. So these features turn to be not really very useful. In contrary, international plan is a very important feature, and we see it's yes/no valued. So actually, it's a binary feature, as well as voicemail plan. And then we've got a bunch of numeric features. The most useful will be total day minutes. So actually the number of minutes on average that clients use their phone. And we've got here on the right, we've got a churn feature. So it's a training set, and for each client, it's known whether a client is loyal, so churn is false, or whether the client is non-loyal or churned, so stopped using services. Okay, and so first we'll deal with some visualizations on the whole dataset. I will call it whole dataset visualizations. And the first one is just to plot histograms of all features. Okay, so it can be done for now for string valued features. So we'll drop state. We can explore state further. But we'll build histograms for all features. So we'll import matplotlib. From here we'll import pyplot, and the common name for that is plt, so as plt. And we'll also use Seaborn library. It relies on matplotlib, and it's much easier to quickly build nice plots with Seaborn. Typical alias is SNS, and this needs to be additionally installed. If you have a local environment, you can do it with pip install Seaborn, so it's really quickly. Or if you've got conda environment, you can do the same, but conda install Seaborn. Sorry, I wanted to say, sorry. Import Seaborn as SNS. Okay. And what we can do is actually taking the whole data frame. We'll only drop text valued features for now, like state. And we'll build histograms for all of these features. Okay, we also have yes/no features. Maybe it requires some pre-processing. Let's try. Okay, it actually can't build histograms for string valued objects for now. Okay, so we need just a bit of pre-processing. So we'll map values for international plan and voicemail plan. So we'll map yes to 1 and 0 and no to 0. Okay, yes will be mapped to 1, no will be mapped to 0. This is a new series, and we will initialize international plan like this. So map doesn't have in place flag, and the very same thing for voicemail plan. Okay, and now if we drop state, this will be all numeric features. Okay, numeric valued here. We'll drop state and churn to see histograms of all other features. Okay, you need to be careful about that, because if you have really lots of features, let's say 300, it's going to take some time, especially if you also have many rows. Here you see plot is not really nice. We need a bit of setting, so RC params will make a figure a bit larger. So here we've got figure fig size. Okay, I'm not sure about the units here, but if you specify something like 16 and 12, it's actually a tuple, then the figure is going to be larger. Okay, and here we see distributions of all our features, almost all of them. So we see, for instance, for international plan, it's a binary feature, and here it's distribution. Only about 10% of clients have this service. Actually, churn is a binary valued feature, so actually it can be, if we turn it as well into 0 and 1, so we can also build a histogram for churn. let's do it as well. So a bit more pre-processing. So we'll do churn as type int. And we need to re-initialize it. dfChurn equals dfChurn as type int. Okay, and we'll also include churn here. It's also interesting because it's a target feature. Okay, and we have the very same plot, but now with churn. Okay, around 15% of clients are not loyal, so they churned. And we can see distributions for all numeric features. They look really very, very close to normal distribution. You might suspect that it's strange because if you deal with real-world data, you'll see that very seldom you see some really nice distributions like normal or Poisson or something else. So you might suspect that it's an artificial data set, but still pretty close to a real one. So it describes you some features like customer service calls. You see the distribution that mostly people make only one call to customer service, but then there is, as statisticians say, it's a skewed distribution, and we've got a long tail of many customer service calls, and we will see that it's a really nice feature here in this dataset. But overall, lots of features can be described with normal distribution. So as a first look at the dataset, this might be useful, just to have histograms of all variables. In this particular case, it's also helpful to build a correlation matrix. So if we call CORR, this will return a correlation matrix. So we see ones on main diagonal. So by default, this is a Pearson correlation between different features. With Seaborn, you can quickly color it with heat map. You'll have such picture. And now it tells us something. Yep. So on the main diagonal, we've got perfect correlation. So the brighter the cell, the higher is the correlation. And we can see that the very same color can be seen in different cells. So let's say here for the correlation between total day minutes and total day charge, it's also correlation 1. And the same for pairs eve minutes and eve charge, night minutes, night charge, and so on. And so we can conclude that actually charges are just correlate perfectly with minutes. So we can conclude that these features are just proportional, and charges are just calculated based on the minutes called. Okay, so actually that raises a question whether we need these features, these charges. So for linear models, we'll see that it can be even a problem if two features are proportional and just have correlation of 1. For decision trees and random forest and boosting based on trees, this is not a problem. So these features can be used interchangeably, either total day minutes, let's say, or total day charges. But actually, this information is not necessary, so it's redundant, and we can drop charge features, let's say, from our dataset. So we can take a look at df columns. We can make a list comprehension and take all features, let's say feature name for feature name in this list. If, so condition, if there is charge in this feature name. If charge in feature name, okay, and this will be our charges, and we can drop these from the data frame. df drop, I'll show you inline documentation. There's a very important flag here, in place. So specifying in place equals false, like by default, will return a new data frame, and the initial one won't be changed at all. So if we do only this and specify that we are deleting columns, axis equals 1, this will return a new dataset without charges. So we can check shape, 16 features, But you see the initial dataset didn't change. So 20 features in the initial dataset. If we'd like it to be modified, we pass in place equals true. Now nothing is returned, and only that the data frame changed, and now we've got 16 features. Okay, some more plots for the whole dataset is TSNE. So it has really very academic name. TSNE stands for T distributed stochastic neighbor embedding. So it's totally not a buzzword like Word2Vec, like anything from Neural World. So an academic paper, it's by Geoffrey Hinton's PhD student and Geoffrey Hinton himself. Okay, so the main idea is this neighbor embedding. So if we've got a d-dimensional space and some distributions of our observations in these d dimensions, we can somehow try to map these points on a plane, let's say. And so if I explain it really simply in a Yellow 5 manner, explain like I'm 5. So it's a really nice way of doing any explanations. So the main idea is that if we have two close points in the initial d-dimension space, we'd like to map them somehow on two-dimensional space so that they are close together. So we make this mapping so that neighbors remain neighbors. And on the contrary, if we have 2 points far away from each other in different parts of space, we'd like to somehow map these on the plane so that they are also distant from each other. Maybe like this. TSNE is a bit of complicated algorithm, so it relies on maximal likelihood estimation, so you can go for an original paper, but essentially the idea is this optimization technique that finds a good mapping from d-dimensional space to a plane or to 3D. So most really often we just use projection on a plane. In 3D we actually don't visualize data as well as on a surface. And TSNE is just some trial to visualize d-dimensional space. I mean, I would say trial because it's only one projection, and of course we can't visualize d-dimensional space. It's only to get some intuition about the data. Okay, so the algorithm is a bit time-consuming. So if you think about it, if you consider all pairs of observations, it will be something, if it got L instances. In a really brute force manner, if we compare all pairs of objects, the complexity will be something like big O of L squared. So actually algorithm is not quadratic, so it's a bit more efficient, but still in practice it requires some time. So I'll show you here in the end the results. So with TSNE we can plot our data like this. So we import TSNE from sklearn manifold, and then we make a TSNE object and build a transformation for our data. And if we plot it, it looks something like that. So just some intuition about the distribution of our data. We've got some blobs, in this case maybe 6 of them. We definitely need to fix random state for that, so the algorithm is very sensitive to hyperparameters, and you can get different pictures if you change random state. You can color this data according to churn, so to separate loyal customers and those who churned. We can build separate features like that for separate plots like that for different values, let's say of international plan. So these orange guys have this service international plan. These blue guys no. Okay, so actually the algorithm became really popular when it visualized MNIST data. So these are handwritten digits from 0 to 9. The space itself is 28 by 28 pixels. We stretch it into this one vector, so it's 784 dimensional. And this is a projection on a 2D plane, and we can clearly see that it creates some blobs for zeros separately, for ones separately, and so on and so on. And so we see that TSNE clearly shows that this higher dimensional space is somehow constructed in a way that handwritten digits are clustered really well. Okay, so actually this icon is also a TSNE visualizations of some dataset. So sometimes it's really not useful, but you can build a really nice plot. So I won't say that it often leads to really very cool intuitions about the dataset, but at least you can see that let's say here we've got a big blob of typical clients, and then we've got some non-typical clients, and we can follow these stretches, these parts of trajectory. Maybe it says that we've got a time axis in our dataset, and these lines correspond to a single client, maybe just just changing in time. Okay, so for visualizing the dataset itself, so TSNE is also a nice technique, but we'll switch to exploring single features one by one, one at a time, features one at a time. And it totally depends on the type of feature. We'll start with numeric features. So if you've got a numeric feature, what you typically do without any plots, let's take total day minutes as the most representative feature. You can do describe to see some of its statistics. You can do something else. You can calculate these statistics separately, mean or standard deviation. What about plots? We can build a box plot that shows pretty much the same thing. So we can do it like this: x equals to total day minutes, and data equals to our data frame. So it's from Seaborn box plot, and we get this this plot. So I think I've already described it in the first lecture. So here's this is a median. So we've got a box, and in the middle there is a line around 170 minutes. It's a median time that folks use actually their phone. Then we have 25% quartile, 75, and here we can track outliers. So these guys almost never use their phone, and these guys use it pretty often. Okay, and of course a histogram. So we've already seen histograms for all features, and for a typical numeric feature you can call a histogram and see its distribution. I'll only return my configurations. The size of the plot will be a bit less. Figure fix size. Let's turn it back to, let's say, 8 by 6. I think these are inches, but I'm not sure. Okay. So actually I'll show you high-level Seaborn properties. If you need matplotlib, you can go to Stack Overflow. So actually I don't remember all these hundreds and thousands of matplotlib settings, only most important. So let's say for the I'll show you some simple settings for matplotlib, how to make your plots customized, a bit more funky, a bit nicer. I'll show them with some nice plot, but generally for preliminary data analysis I just use Seaborn or pandas methods built upon matplotlib, like this, like histogram. So I take PD series, I call histogram, and it builds a histogram just upon matplotlib functions. Okay, so it's about the distribution of a numeric feature. If we have a categorical variable, then how do we explore this distribution? Without any plots, this will be at first checking the number of unique values to make sure it's limited. So let's take state. N unique will show us that there are 51 unique values for state. And if we'd like to know its distribution, we can just call value counts. And I restrict to only see 5 rows. Okay, 106 guys are from Wyoming, 84 are from Minnesota, then New York, maybe Alabama, OR, okay, I'm not sure. But still, that's the distribution of a categorical variable. Here we've got churn, which is a binary variable, and it's a special type of a categorical. And it's really nice to calculate value counts for this feature to understand your target variable. So it's 483 churned users. We can normalize to get percentages. Normalize equals true, and we see that there are 14.5% of churned users in this dataset. Okay, the very same can be built with a count plot, Seaborn count plot. You pass a name of a variable, let's say churn, and then data is our data frame, and we get the very same, but as a plot, as a picture. Sometimes you see that you are going to think a bit before plotting, before making a plot, because if you do the very same for state, you see the picture is very, very vivid, so it's overwhelmed. So maybe you don't need actually this picture. So Seaborn takes care about coloring, about putting these ticks, about naming axes. So it's a really nice wrapper around matplotlib functions. But maybe for this 51 site, this plot is not really helpful, or maybe a bit overwhelming. Okay, now let's switch to feature interactions. So it's interaction between feature, how we visualize these. And let's start with numeric interaction. So we'll be interested how two numeric features are distributed. I would say this dataset is not perfect for investigating such thing, because our target variable is binary. And these plots are extremely helpful. Okay, so they're reasonable only in the case when we explore it with a target variable. So it's not really very reasonable to just explore two features. It's much better if one of them is a target variable, because we'll be going to predict it. So in a regression task where we'll have a numeric target variable, this will be a much better thing to do. But here I'll just show you that for numeric and numeric interaction, we can build a scatterplot. PLT, so from matplotlib, scatter. We can pass just two numeric features, like total day minutes, and another one, let's say, customer service calls. So this is not 100% numeric, yeah, because customer service calls won't take any value, not float values. Only that for these two features, maybe a plot will be a bit more interesting. So we can do such plot. It shows us total day minutes as an x-axis and customer service calls as y-axis, and these are our observations. Maybe the only helpful thing will be to take a look at these outliers. So these guys call to support very often. At the same time, they make many calls. but otherwise, I won't say it's really helpful, but in regression tasks that we'll do in our second competition, these plots can be really, really very important. So it was a plot, a scalar plot. I promised to first say how we can explore it without plots, and then only then with visualization. So actually I don't know really nice ways of exploring numeric and numeric interactions without plots. Maybe only correlation. Yep. So we can take a look at correlation. Let's say total day minutes, and take a look at correlation. Okay, let's take a look of correlations with the total day minutes variable. One moment, df core with, yep, sorry, no underscore here. And we need to drop again string valued features. Okay, so let's save states as a separate series object, df state, and then we'll drop feature state from our data frame. Drop state, again axis equals 1, and we do it in place. In place equals true. Okay, and we calculate all correlations with total day minutes. Okay, again I've left something else. Let's take a look. df head. Okay, so all features except for all features are numeric. Okay, let's just take a look. So df core with computes pairwise correlations between rows or columns. So we actually need to pass a series here. Okay, and these are all correlations of all features with a total day minutes feature. And we can take a look that, let's say, night minutes or eve minutes. Okay, they actually don't really much correlate with total day minutes. So I would say the most preferable way to study relation between two numeric features without making plots is actually calculating correlation. Okay, let's switch to categorical and categorical. So this can include binary. So binary is a special case of categorical variable. So we can calculate crosstab, and we pass two categorical variables. So now we've got a churn. It's a binary feature, so it's now it's much higher motivation actually to study interactions between features, because target feature is actually binary or special type of a categorical. And we can pass here another categorical variable. Let's say, what else we've got here? Okay, actually, customer service calls can also be treated as categorical because the number of unique values is restricted. Okay, and we can build a crosstab like this. So we can calculate, we can use this result because it's a special data frame. We can save it into another variable, but of course it's better to visualize it. And so here, for categorical and categorical interaction, we'll also build a count plot. So we'll pass customer service calls as a x-axis, and okay, I'll write this comment and explain it to you. Okay, here we see this plot. On x-axis we've got customer service calls 0, 1, 2 and so on till 9. And on y-axis we've got counts. and this picture is colored by the churn variable. So this was the hue argument, and we see so what we see is that blues are loyal and orange are ones, so loyal and non-loyal customers. And from this plot we can make a really nice conclusion that with many service calls people start to churn. Okay, this might sound really obvious and intuitive because the features are very clear and it's easy to deal with them. But if these are something more complicated, if we deal with physics, let's say, we start exploring features, make visualizations, it's not that obvious each time. Okay, and here we find some intuition that okay, I'm actually repeating the material of the previous lecture, but now we go into details how we did it with CountPlot. We find some intuition that starting from 4 service calls, the fraction of churn really increases very much as compared to the cases where there are almost no service calls. Okay, at this point I'll show you how to make a plot a bit nicer. So okay, Seaborn here does really a lot. We can put a title with PLT title, so we can call it customer service calls for loyal and churned. And now we've got a title. So actually by default in Jupyter cells you see the type of object that you print. So in order not to see this type of this object printed, you can put a semicolon, and now you've got a title for your plot. Well, actually there is no more interesting to do with this plot. So, but if you build some plots with matplotlib, you can put labels for axis. You can put legend. And so on. Okay, let's return and okay, I'll actually show you these nitty-gritty details about matplotlib with this example of TSNE picture. Okay, it actually took not much time to build a TSNE plot. I'll reproduce it here. And okay, let's build some plot, and I'll show you some details how you can make it nicer with matplotlib. Okay, so TSNE was here about describing the data set on its own, once at a time. So let's do it here. Sorry, here, just after. So we did it just after the correlation metrics. Okay, from sklearn manifold, we import TSNE. You can take a look and read about this method. So the documentation is really very long and interesting if you're going to dive into these specifics into this algo. Okay, so we'll take our df shape. Take a look, 15 features left. And actually I'm here ordering, I'm changing the order of execution of the cells. It's not really very good. Let's say I'll restart the notebook and execute it from the beginning. Because we deleted state variable, and it's not very nice, cool thing to do, to first execute some cells in the beginning, then in the end, then in the middle. because here at this point we actually have this feature state. So what I'll do here, I'll save it in a separate variable, df state, and I'll drop it. Actually, many folks hate Jupyter notebooks exactly for this. Again, a small detour. If I say that a equals to 1, then in the next cell I delete this variable, and then I execute this cell again. Sorry, I meant I'd like to print this variable. Okay, so I'm initializing a to be equal to 1, then I print it, then I delete it, and then I mix the order of execution and print a again. Of course, I have a name error that a is not defined. So pretty often, if you execute all cells from the beginning just by kernel, restart and run all, you'll have some errors like this because the order of cells is actually broken. Okay, that's why I'll do it here. I'll drop state in this cell. Okay, and now I'll create a tsyn-e object. I'll fix random state. And we see all features now shall be numeric. And let's build these plots for churned separately and for loyal. Okay, a tsyn-e transformation will be done like this. So we'll build some representation of our data set. Let's call it wrapper. It will be tsyn-e fit transform and our data df. But let's build two of them, so specifically for loyal and for churned. Churn equals 1. This will be churn. And the very same, but for loyal. Okay. Or maybe, okay, maybe simpler. I'll start with building a representation for the whole dataset, but then our visualization will depend on whether a customer is churned or loyal. Okay, so let's build it for the whole dataset. And now we'll have some representation. Let's take a look at its shape. So what it's actually doing now, it finds some nice projection from 15-dimensional space into a 2D plane, so that to save this idea of neighbor embedding that I explained to you previously. Okay, and then I'll show you a scatterplot and go into these details of visualization, of actually putting some labels and titles. I'll show you it only once, just basic matplotlib stuff. Well, you see, it requires some time. Maybe while it's calculating, I'll show you the result, what's going on there. Yes, okay, I skipped scaling, so for this algorithm it's better to scale data, but we'll take a look, we'll see something like that, and we'll build this plot for churn and for loyal people. We will have separate scatter plots, and then we'll just put ticks, put labels on axis. We'll have a title, we'll save it to a file. Just a bit of working with matplotlib. Okay, so now we've got a representation. 3,3333 rows and 2 columns. And we can build a scatterplot taking this X representation. So first all rows and first column, and then all rows and second column. Okay, so this is the scatter plot. You see now it can be different from the picture that we got there. So I skipped scaling data here, though TSNE would require scaling. Okay, and so this is some embedding of our points onto a plane. Let's just make it a bit nicer. So again, I'll make a picture a bit smaller. Okay. 8 and 6. And we've got a scatter plot. I'd like to color it based on the target variable on churn. So let's make actually 2 scatter plots. Here I can subset by df churn equals 1. The same here. And here I can subset loyal customers, df churn equals 0. Okay, it's better to write it here like this. Representation. Just one moment. Yeah, sorry, a bit tired. Yeah, of course, double equal sign. Okay. And now we've got 2 scatter plots. Actually, it doesn't show here very nice difference. But speaking about building plots, so we've got scatter plot, and it's better to make it more visible. We'll add transparency. Alpha something less than 1 will stand for transparency. And now we see blue and orange dots intermingling. Okay, so the plot is not really very much helpful. So according to this plot, loyal customers are just the same as churned. But let's just speak about a little bit about visualization. So here with TSNE, X and Y axis actually don't make any sense. These are just TSNE representations. So I'll put only a title. Title is TSNE representation. Okay, just to show how you put labels, I can specify X label. This will be TSNE axis number 1. Actually, no sense in specifying this, but just to show you techniques, X label and Y label. Okay, now we've got the very same picture, but with labels. I can also put a legend. So I want to show that blues are, by the way, who. Yep. So I would like to specify color and specify a legend. Okay, so here I'll specify color. Blue will be churned, and orange will be loyal. And I'll put also a label. Label churn, and here label loyal. And finally, to see these labels on the plot, we need a legend, plt legend. So actually it's built upon all this matplotlib, built upon MATLAB syntax. It's functional programming, and so you just need to get used a bit with it. Okay, so now we've got a legend. Blues are churn, this orange or even yellow are loyal. And finally, let's save it as a PNG file. So we can save fig, specify location. Let's say churn tsne PNG. What I typically do is I only specify DPI. It's for resolution, so 300 points per inch. I don't remember defaults, but this will be a bit nicer. And now I'll have the very same picture, but as a PNG file. So now I can include here EMG SRC and this tsne churn tsne file, churn tsne PNG. Okay, I converted to markdown cell, and now the very same picture. Okay, you see the resolution is a bit nicer. Okay, let's move on. At this point, remember we dropped state, so we already executed it. So here we don't need this cell anymore. Sorry, not this one. Okay. Okay, so this shall have state. All right, now let's move on. Actually, I can execute everything below. So there is a possibility in Jupyter Notebooks to do this, run all above or run all below. Okay, and so we stopped here at the interaction of categorical and categorical variables. And the last one will be exploring interaction between a categorical variable and a numeric one. And so here we typically, if we don't build plots, we'll calculate some statistics of a numeric feature with different values of a categorical one. So we covered all these group bys and applies, so the previous time. So we can take our data frame, group it, let's say, by churn target variable, then select some features we'd like to get. Okay, so here we select columns like total day minutes and customer service calls. And then we can calculate, let's say, mean of all these values. And we've got, for loyal and churned, we've got mean total day minutes and mean customer service calls. Or we can import NumPy to take some simple functions from there. And with aggregate, with AGG, we can pass here any function, let's say NP median, and we can calculate medians, or even to pass a list of functions. Let's say we need to calculate both median and STD. Okay, so here how we get the result. So for investigation, these interaction between categorical and numeric variables. As for visualizations, again, the box plot will be really helpful. So for x-axis, we specify categorical variable or churn in our case, and for y-axis, we can specify, let's say, total day minutes. Okay, and now we see two box plots, and this one is also very interesting. So it says that churned clients actually speak more on phone than loyal customers. So this is actually an insight into data. This needs to be investigated a bit more. But according for this data and with help of this plot, we can conclude that we actually see the difference. Okay, so actually this material will help you to okay, some typos now, typos now. Okay, so I'll share this notebook with you, but here we actually covered some typical plots that you do to actually get acquainted with your data, explore features, explore feature interactions. So as for me, typically these are the plots that I build when I first get a data set and when I know my target variable, and I explore all the features to actually better predict the target variable. And it's also very, very cool for feature engineering. Like in this case, when we had an insight how customer service calls influence the target variable. So here we created a feature, many service calls. So it's a really nice source of insights for feature engineering. Okay, and finally, as a call for actions, I encourage you to go here for Kaggle datasets, find mlcourse.ai. So you can just start typing it, mlcourse, so here in datasets. Here we've got kernels, and you can do a practice. So practice is supposed to be something really simple, just to get used to what we discussed in lecture. So I forgot to tell you about topic 1 practice. Now we've got solution here, and for topic 2, for visualization, we've got the very same Titanic dataset, so we can just practice a bit with all visualizations. It already goes with a solution, so it's just upon you how much time you need to spend on that. Just to build some really simple plots and to practice what we discussed here. You see all these pictures, just typical plots you do. Okay, so good luck. And in assignment 2, you'll also beat lots of plots, and so good luck with that as well.